Welcome to the module on sampling methods. By the end of this presentation, you would have understood the concepts of sampling, learnt about different methods or techniques of sampling. You would be able to differentiate between probability and non-probability sampling, and you would have clearly understood the appropriate applications of sampling methods or techniques. Let us try to understand what is sampling. The process of selecting a predetermined number of individuals or units as being representative of a population from that population in order to better understand and observe the characteristics of that population is known as sampling. When the population being studied is too large to be covered in totality and the process of selecting each and every unit is more cumbersome and expensive for the study, a sample is then selected as a representative of this population and thereby studied. Let us see what is a sampling frame. A sampling frame is the source from which a sample is drawn. It is nothing but a list of all those units within the population which are likely to be and can be selected or sampled. The sampling frame may include individuals, households, institutions, etc. Now, what is a sampling bias? Sampling frames may not always be perfect. They may have consistent errors which arise due to the sample selection. This usually leads to a sampling bias. It can occur if your sample is not a random sample. In that case, some individuals are more likely to get represented or chosen in your sample than the others. Remember, such sampling biases should be identified prior to the other analysis and tried to minimize. What are the problems of sampling frames? According to Leslie Kish, 4 basic problems of sampling frame can be stated as: first, missing elements. Here, some members of the population are not at all included in the frame. Second, foreign elements. In this case, the non-members of the population are also included in your sampling frame. Third, duplicate entries. In this case, a member of the population is usually surveyed more than once. And finally, groups or clusters. In these examples, the sampling frame actually lists the clusters or groups instead of the units as individuals. Let us see what is a sample size. Selecting an adequate sample size is an important feature of sampling process. It is typically denoted by small n, alphabet n, and it is always a positive integer. It is determined by the size of the population. So, remember, larger and more heterogeneous your population, larger would be the sample size. It also depends upon the frequency of occurrence of a particular trait, behavior or element that is being researched in that population and is represented in the sample. However, all else being equal, large sample size always leads to increased precision in estimates of various properties of your population. Let us come to the various sampling methods. Sampling methods are classified into either probability sampling or non-probability sampling. In probability sampling, each member of the population has a known non-zero probability of being selected. That is, every unit in the population has a chance which is always greater than 0 of being included in the sample, and this probability can always be accurately predetermined. It involves random selection at some point. Probability sampling methods include random sampling, systematic sampling, stratified sampling and cluster sampling. Now, what is non-probability sampling? Non-probability sampling is a sampling method where some elements of the population have absolutely no chance of being selected in your sample, or where the probability of selection cannot be accurately predetermined. It involves the selection of elements based on assumptions regarding the population of interest, which forms the criteria for selection. Non-probability sampling methods normally include convenience sampling, judgment sampling, quota sampling and snowball sampling techniques. Let us see the basic and the foremost simple random sampling. Random sampling is the purest form of probability sampling. Here, each member of the population has an equal and known chance of being selected into your sample. However, simple random sampling can be vulnerable to the sampling errors because the randomness of the selection may result in a sample that does not reflect at all the makeup of your population. For example, in a study of adolescent girl dropouts, a school register may provide information on all the dropouts, both girls and boys. Hence, the researcher would need to be specific during the sampling process. Random sampling may also be cumbersome and tedious, particularly when the target population is very large. For example, if you have to study children in Maharashtra, entire Maharashtra who have dropped out of school, in that case random sampling would be difficult. Now let us see what is systematic sampling. Systematic sampling is often used instead of random sampling. It refers to arranging the study population according to some ordered scheme, and then elements are selected at regular intervals, also known as the sampling interval, through that ordered list. Remember, the starting point is not automatically the first in the list, but is instead randomly chosen from within the first to the nth element in that list. Thus, systematic sampling involves a random start and then proceeds with the selection of every nth element from that unit onwards. Let us come to stratified sampling. Stratified sampling is commonly used probability method that is superior to random sampling because it reduces the sampling error. A stratum is nothing but a subset of a population that shares a common characteristic. Relevant stratums are then identified with the actual representation in the population. A random sample is then selected from each strata and used for the study. This sampling method has many advantages. When a population is divided into distinct independent strata, a wealth of specific data can be garnered, enabling the researchers to draw inferences about specific subgroups. This further enriches the study and prevents important data from getting lost, as may happen in a random sample. Let us see the advantages of stratified sampling over the other sampling methods. This type of sampling focuses on important subpopulations and ignores the irrelevant ones. It also allows the use of different sampling techniques for different subpopulations. This type of sampling improves the accuracy and efficiency of estimation. It also permits greater balancing of statistical power of tests of differences between the strata by sampling equal number from the strata varying widely in size. There are also a few disadvantages of the stratified sampling technique. This technique requires selection of relevant stratified variables, which may be difficult at times. It is also not useful when the subgroups are not homogeneous. Moreover, it can be an expensive and a time consuming procedure to implement. Let us come to cluster sampling. Cluster sampling is a probability sampling method in which each sampling unit is nothing but a collection of elements together termed as clusters. Here, the total population is divided into groups or clustered, and then a simple random sample of these clusters is selected. An important point to be noted here is that the population within a cluster should ideally be as heterogeneous as possible, but there should be homogeneity between the two clusters. Also remember, the clusters should be formed in such a way that each cluster should be a small scale representation of your entire population. Thus, the clusters in nutshell should be mutually exclusive but collectively exhaustive. Let us see an example of cluster sampling. Cluster sampling may be commonly implemented as multi-stage sampling. This is nothing but a complex form of cluster sampling in which two or more levels of units are embedded one in the other. An example of this would be the study of efficacy of pulse polio immunization program via the primary health centers. Here, the researcher could select all the rural health centers in the state for the study at the first stage. In the second stage, a sample of primary units is randomly selected from each cluster rather than using the units contained in the selected cluster. This would be all the children less than 5 years of age. In the subsequent stage, in each of these selected clusters, additional sample of units are selected and so on. The ultimate units, that is the children under 5 years of age, for instance, selected at the last stage of this procedure are then surveyed. This technique thus is nothing but the process of taking a random subsample of the preceding random sample. Let us now come to non-probability sampling, the first of which is the quota sampling. In quota sampling, the population is first segmented into subgroups. Then, judgment is used to select the subjects or the units from each segment based on a specified proportion. Since the selection of the sample is based on judgment, clearly it is a non-random technique. Choice-based sampling. In choice-based sampling, the data are stratified based on a particular target. A sample is taken from each stratum so that the rare target class will get more chance of being represented in the sample. Here, there is a strong possibility of the researcher bias getting introduced, and so the sample remains no longer random. The third is the convenience sampling. The sample here is selected because they seem convenient. It is usually used during preliminary research efforts to get a gross estimate of the results. It is a very inexpensive and a time-saving method. The fourth is the judgment sampling. Here, the researcher selects the sample again based on a judgment. This is nothing but an extension of convenience sampling. In this case, the researcher must be confident that the chosen sample is truly representative of the entire population. The last and the final in non-probability sampling technique is the snowball sampling method. Here, the snowball sampling relies on the referrals from the initial subjects to generate additional subjects. But many times the initial subjects tend to nominate the people that they know well and may probably share particular characteristics or traits with. So, the sample here would therefore not be representative of the population. Let us come to the sampling errors and bias. Let us now see what are sampling errors and sampling bias. Sampling bias undermines the external validity of a test. In other words, it undermines the ability of its results to be generalized to the rest of the population. On the other hand, selection bias addresses the internal validity for differences or similarities found in the sample at hand. Therefore, errors which occur in the process of gathering the sample causes sampling bias, while errors in the process thereafter cause selection bias. What are the types of sampling bias? These include selection from a specific area, self-selection bias, pre-screening of trial participants, exclusion bias, healthy user bias and Bergson's fallacy. Let us now see what are non-sampling errors. Non-sampling errors are the other errors which can impact the final survey estimates. These are usually caused by the problems during data collection, processing or during the sample designing. These include first, over coverage. This is nothing but inclusion of the data from outside of the population. Under coverage, in this case the sampling frame does not include elements in the population. Third, measurement error. Here the respondents misunderstand a question or find it difficult to answer and thus an error is introduced. Fourth, processing error. This happens usually when there are mistakes in either data coding or data entry. And finally, non-response, which is nothing but failure to obtain complete data from all the selected individuals in the sample. Let us summarize the entire module. The process of selecting a predetermined number of individuals as being representative of a population from that population in order to have a better understanding and observe the characteristics of that population is nothing but sampling. A sampling frame is the source from which the sample is drawn. Problems of sampling frame include missing elements, foreign elements, duplicate entries and cluster or group listing. Sample size is nothing but the size of your sample. It is determined by the size of the population and frequency of occurrence of trait, behavior or element which is being researched in the population. Sampling methods are classified based on probability sampling or non-probability sampling. The probability sampling methods include random sampling, systematic sampling, stratified sampling and cluster sampling. On the other hand, non-probability sampling methods include convenience sampling, judgment sampling, quota sampling and the snowball sampling techniques. Sampling bias undermines the external validity of the test, that is the ability of its result to be generalized to the rest of the population. On the other hand, selection bias addresses the internal validity for differences or similarities found in the sample at hand. Sampling bias include selection from a specific area, self-selection bias, pre-screening of trial participants, exclusion bias, healthy user bias and Bergson's fallacy. On the other hand, non-sampling errors which can impact the final survey estimates include over-coverage, under-coverage, measurement error, processing error and non-response. Hope this module has given you a good understanding of the basic sampling methods. Thank you.